Picture a quiet, moonless night. You look up at the sky, scattered with a myriad of stars. Every single pinpoint of light is a distant sun, perhaps complete with its own planetary system. The universe feels infinite, brimming with wonder. Now imagine that one of the most powerful telescopes ever created by humanity is focused on a tiny, utterly unremarkable patch of that very sky. It stares for hours, days, even weeks, gathering light that has traveled across millions of years. And then in the resulting image, amidst the dazzling scatter of galaxies and nebulae, scientists spot something impossible. They see a shadow, a perfectly delineated coal-black shadow. But the strangest thing about it is that there is absolutely nothing there to cast it. This wasn't just a dark patch, it was a void where something should have been. Today, we are going to dive deep into the story behind this mysterious photograph. We will attempt to understand exactly what the telescope saw and why this shadow without an object became one of the greatest riddles in modern astrophysics. Prepare yourself for a calm journey to the edge of the known universe, where the laws of physics clash with the inexplicable. To fully grasp the magnitude of this enigma, we first need to discuss the instrument that discovered it. We are talking about the hypothetical orbital telescope, the Eye of the Horizon. This is neither Hubble nor James Webb, but a fictional next-generation apparatus designed specifically to hunt for the faintest and most distant objects in the cosmos. Its primary mirror, composed of hundreds of hexagonal segments, spans nearly 50 meters in diameter, allowing it to capture photons that have been traveling toward us since the dawn of time. The telescope operates across a wide spectrum, from infrared to ultraviolet, giving it the capacity to see through dense dust clouds and analyze the chemical composition of distant stars. Project Deep Field was its primary mission. The telescope was instructed to gaze at a single point in the Fornax constellation for several months, aiming to create the most detailed image of the universe ever recorded. It was during this mission, while analyzing terabytes of data, that the team led by astrophysicist Dr. Evelyn Reed discovered the anomaly. This wasn't just an area sparse of stars, it was a patch of absolute blackness that appeared to absorb or block the light from the galaxies situated behind it. While science is familiar with such dark spots, they always have a traceable cause. Here, there was none. This moment marked the beginning of a story that forced scientists to fundamentally reconsider the very basis of our understanding of the cosmos. As expected, Dr. Reed's team's initial reaction was denial. It had to be a malfunction. In an instrument as complex as the Horizon's Eye, a fault could originate virtually anywhere. Perhaps it was just a dead pixel on the detector's massive array. Or maybe a high-energy cosmic ray struck the sensor at an inopportune moment, causing a temporary glitch. The first few weeks were dedicated entirely to a meticulous hardware audit. Engineers back on Earth ran hundreds of diagnostics, scrutinizing the telescope's telemetry from every single moment of observation. They checked the mirror calibrations, the status of the cryogenic cooling system, and the algorithms processing the raw data. Every system was operating flawlessly, no anomalies, no faults. Suspicion then shifted to image processing artifacts. Perhaps the algorithms responsible for stitching thousands of individual exposures into a single panoramic image had failed, fabricating this black smudge. Programmers rewrote segments of the code and employed alternative processing techniques, yet the shadow remained precisely where it was, unwavering in shape or size. It was a legitimate component of the data, not a ghost in the machine. This phase of ruling out technical errors was crucial. It drew the line between a routine operational hiccup and a potentially profound discovery. Every subsequent check, confirming the telescope's perfect health, only amplified the team's excitement and bafflement. They were on the brink of something unprecedented, and this new phenomenon currently defied explanation. The shadow wasn't just a dark spot, it behaved like a perfect light sink, completely blocking the emission from distant galaxies, the light of which was clearly visible around the anomaly's edges. This meant that something physical was positioned between us and those galaxies, but what could it possibly be? Once technical errors were completely ruled out, the scientists shifted their focus to astronomical explanations. The first and most obvious hypothesis was a dark nebula. Our galaxy, the Milky Way, contains countless such objects. These are giant clouds of incredibly cold molecular dust and gas, so dense that they completely block the light from the stars behind them. In photographs, they appear as black voids in the starry sky. The most famous example is the Coalsack Nebula in the constellation Crux, or the Southern Cross. Could this mysterious shadow be something similar? The team pointed the eye of the horizon's other instruments at the object, specifically its infrared sensors. The reasoning was this: even though the dust in these nebulae is extremely cold, it still emits a faint thermal signature in the infrared spectrum. It's like looking for a black cat in a dark room using thermal imaging. But when they observed the shadow in infrared light, they saw absolutely nothing, absolute zero, no radiation whatsoever. This was extremely perplexing. Any cloud of dust, even the coldest imaginable, should have been glowing slightly with heat. Furthermore, the edges of the shadow were too sharp, too clearly defined for a standard gas and dust cloud. Nebulae typically have blurry, fractal boundaries, yet this anomaly was almost perfectly circular, as if cut with a compass. This flawless geometry completely contradicted the chaotic nature of interstellar clouds. The dark nebula hypothesis, which initially seemed so logical, collapsed upon the first serious test. The mystery only deepened. If it wasn't dust and it wasn't gas, then what entity was capable of blocking light so perfectly while leaving no other trace of its presence? Next up on the list of astronomical suspects was a black hole, specifically a stellar mass black hole that might have been aligned perfectly with our line of sight. A black hole itself is invisible, but its immense gravity profoundly warps the surrounding space-time. One key effect is gravitational lensing. A massive object like a black hole bends light rays coming from galaxies far behind it, much like a conventional lens. If this black hole were positioned exactly between us and a distant galaxy, we would see characteristic distortions. The galaxy's light would likely be stretched into a ring known as an Einstein ring, or split into multiple, distinct images. Dr. Reed's team meticulously analyzed the light from galaxies located right at the edge of this mysterious shadow. They were searching for the slightest trace of gravitational distortion, but they found none. The light from the background galaxies was utterly undisturbed. It simply cut off sharply at the shadow's boundary, as if an absolutely black curtain had been hung in space. This was a serious argument against the black hole hypothesis. One could theorize that it was an incredibly low-mass black hole that wouldn't cause noticeable lensing, but then it couldn't possibly cast such a massive shadow. A major contradiction emerged. Furthermore, black holes, even isolated ones, are often surrounded by an accretion disk, material spiraling inward that heats up to immense temperatures, emitting powerful X-rays. Scanning the region in the X-ray spectrum also yielded nothing. Zero signs of activity. The object was both gravitationally and electromagnetically silent. It was simply there, blocking the light, but otherwise refusing to reveal itself in any conventional way. Trying to describe it felt like trying to describe a ghost. You know it exists, yet no instrument can definitively register it. The black hole hypothesis was discarded just like the previous ones. The list of standard astronomical explanations was rapidly running out. When standard explanations in science fall short, it's time to entertain bolder, even truly exotic ideas. The team began considering the possibility that this shadow object was something fundamentally new, something we'd never seen before. One of the leading exotic concepts was an object made of strange matter. Theoretical models suggest that under extreme conditions, for instance, inside a neutron star, protons and neutrons can essentially melt into a dense soup of their fundamental constituents, quarks. If this quark soup were dominated by what are called strange quarks, it could form a stable configuration of matter known as strange matter or a strangelet. Theoretically, such an object would be unimaginably dense and perfectly black, absorbing all light without reflection or emission. Crucially, if its mass were limited, it wouldn't produce significant gravitational lensing. This appeared promising. It fit the observation of blackness perfectly. But there was a major catch. According to the theory, if a strange layer were to collide with normal baryonic matter, it would initiate a chain reaction, catalytically converting the ordinary matter into strange matter. This process would be irreversible and accompanied by a violent burst of energy. The object in question has likely existed in space for millions, perhaps billions of years. During that immense timescale, it absolutely should have encountered particles of interstellar gas, yet there were zero recorded signs of this interaction, no flares, no energy bursts. The object wasn't just quiet, it was utterly inert. It simply did not interact with its environment. This fact alone made the strange matter hypothesis highly improbable. It solved the problem of the object's blackness, but it failed completely to account for its total passivity. The scientists were back at square one. Every proposed theory seemed to neatly resolve one enigma while simultaneously introducing a new, equally complex paradox. The mystery was becoming increasingly layered, suggesting that a simple, straightforward answer likely didn't exist. When scientists exhausted all avenues related to matter, no matter how exotic, their gaze naturally shifted to the very fabric of space-time itself. Cosmology posits the existence of topological defects, relics from the universe's infancy left over from phase transitions similar to water turning into ice. One such type of defect is the cosmic string, hypothetical, incredibly thin, yet extraordinarily dense filaments of energy that could span truly astronomical distances. Should such a string, perhaps coiled into a closed loop, cross our line of sight, its behavior would be truly bizarre. While it wouldn't emit or absorb light in the conventional manner, its sheer energy density would generate an immense gravitational field. This, however, immediately reintroduced the problem of expected gravitational lensing, which crucially had not been observed. Yet, certain theories proposed even more elaborate defects, such as domain walls, two-dimensional membranes separating distinct regions of the vacuum. Such a wall, if viewed perfectly edge-on, might be able to block light without generating strong gravitational effects along its edges. This was a highly speculative concept, resting right at the frontier of modern theoretical physics. Verifying it experimentally was essentially impossible. It felt less like a testable scientific hypothesis and more like a philosophical exercise. Nevertheless, the mere fact that serious scientists were entertaining such concepts spoke volumes about the truly anomalous nature of their discovery. They were ready to accept that they might have peered behind the curtain of familiar reality and witnessed something that simply does not fit the standard model of cosmology. Perhaps the shadow wasn't an object in space, but a fundamental defect of space itself. This realization was simultaneously terrifying and incredibly exciting. It threw open the doors to an entirely new realm of physics. This brings us to one of the most intriguing and arguably the most important hypotheses to emerge from these discussions. What if we are dealing not with an absence of light, but an absence of something else entirely? What if this observed phenomenon is actually a shadow in the field of dark matter? Let's quickly recap what dark matter is. It's the mysterious substance believed to make up about 27% of the total mass energy of the universe. We cannot see it. It doesn't emit, absorb, or reflect light. We only know of its existence through its powerful gravitational influence on visible matter, on stars and galaxies. Now imagine that dark matter is not perfectly uniform. What if, much like regular matter, it can form both dense clumps and, conversely, absolute voids? What if the observed shadow isn't an object blocking light, but rather a kind of bubble or hole in the distribution of dark matter itself? Such a bubble would inherently possess less gravity than the space surrounding it. Light from distant galaxies passing near the edges of this void wouldn't be attracted. Instead, it would experience a kind of push, an effect known as negative gravitational lensing. This effect would make the region appear darker to us because the light passing through that area would essentially be scattered away from our line of sight. This hypothesis was both elegant and compelling. It perfectly explained the lack of emitted radiation and the absence of standard gravitational lensing. Crucially, it also accounted for the sharp, distinct edges of the anomaly, but it suffered from one major flaw. It was purely theoretical. We still don't know what dark matter is composed of, and we certainly don't know if it can form such stable, internal bubbles or voids. If this hypothesis were ever confirmed, it would represent the first direct observation of structure within dark matter, a discovery certainly worthy of a Nobel Prize. Dr. Reed's team quickly realized that verifying this idea would require new data, new observations, and perhaps the use of entirely different instruments. Despite every effort to keep it under wraps, news of the discovery began trickling out to the scientific community. It started as whispers and rumors, then turned into anonymous messages posted on astrophysics forums. When Dr. Reed's team finally published their paper in a prestigious scientific journal, it hit the community like a bombshell. The world of science instantly split into two warring camps. Skeptics insisted that the finding was likely some previously unknown artifact, or perhaps a rare combination of familiar phenomena that merely mimicked the shadow. They demanded far more compelling evidence, specifically requiring independent verification from other observatories. On the flip side, many scientists enthusiastically embraced the news, viewing it as confirmation that we were standing on the cusp of entirely new physics. A full-blown race was now underway. The world's largest telescopes, both ground-based and orbiting, immediately shifted their observation schedules to focus on the mysterious patch of sky in the Fornax constellation. Radio astronomers pointed their massive dishes toward the area, desperate to catch even the faintest signal. Neutrino and gravitational wave specialists also joined the frantic search. Everyone wanted a piece of this historic discovery. For Evelyn Reed's team, this was an incredibly stressful time. While they were the center of global attention, they also bore an immense weight of responsibility. Any flaw in their initial calculations could instantly destroy their professional reputations. They cross-checked their data relentlessly, fighting off attacks from critics while scrambling to find new ways to definitively prove their findings. The atmosphere was electric with anticipation. The entire world held its breath, waiting for what the other telescopes would reveal. Would they confirm the existence of the shadow or debunk it entirely? In science, especially in a field like astronomy where the objects of study are at unimaginable distances, independent confirmation is the gold standard. A single observation, no matter how compelling, can be a fluke. But when 2 or 3 different telescopes, located across the globe or even in space, see the exact same thing, that's when it becomes a fact. The first independent confirmation came from the European Southern Observatory in Chile. Their very large telescope, using entirely different technology and data processing methods, imaged the exact same patch of sky. And the shadow was there. It was identical to the images captured by the Horizon's Eye, delivering a powerful blow to the skeptics. Next, the Chandra X-ray Observatory joined the investigation. It saw nothing which, surprisingly, was an important confirmation. The area of the shadow lacked any evidence of high-energy processes. The ALMA radio telescope array, situated in the Atacama Desert, also failed to register any millimeter wave radiation, effectively ruling out the hypothesis of a cold gas or dust cloud. Step by step, observation after observation, the scientific community reached a consensus. The anomaly was real. It wasn't an error, nor was it an artifact. Something truly existed in deep space, casting a perfectly black circular shadow without manifesting itself in any other way known to science. The main question was no longer, does it exist, but rather, what is it? And here, opinions still diverged sharply. Every group of researchers proposed their own, sometimes wildly speculative, theory, and the debates in lecture halls and the pages of scientific journals reignited with new intensity. Among the countless theories debated in the scientific community, there was one most researchers only dared to mention in hushed tones, usually relegated to the back rooms of conferences. This was a hypothesis that stretched beyond conventional natural explanations, dipping deep into the territory of science fiction. What if the shadow was, in fact, an artificial object? What if it was a megastructure built by a highly advanced extraterrestrial civilization? The concept of the so-called Dyson sphere had been initially proposed by physicist Freeman Dyson back in the 1960s. He theorized that any civilization reaching a critical level of technological maturity would eventually seek to harness the entirety of its star's energy output. To achieve this, they would construct a colossal shell around the star designed to capture all its emitted radiation. From the outside, such a structure would be almost optically invisible. However, it would necessarily radiate strongly in the infrared band as it vented colossal amounts of waste heat. The observed shadow, however, displayed no detectable infrared signature, directly contradicting the classic Dyson sphere model. But what if it wasn't a sphere at all, but something else entirely? Perhaps a colossal screen designed specifically to mask an ongoing celestial operation, or even a light-absorbing portal into another universe. These ideas were, admittedly, pure speculation. There was zero concrete evidence to support an artificial origin for the object. Yet definitively disproving the hypothesis was equally impossible. It remained on the periphery of scientific discourse, a stark reminder that the universe might be far stranger and perhaps far more inhabited than we were comfortable imagining. Dr. Reed and her team diligently avoided this topic in their official publications, choosing instead to focus strictly on verifiable physical models. But deep down, every single one of them, gazing at the perfectly circular shadow on their monitors, couldn't help but wonder, what if we aren't alone? Let's pivot back to some more scientific, though no less astonishing, hypotheses. One of these involves string theory and the concept of extra dimensions. According to this theory, our universe isn't everything that exists. It might be just a three-dimensional membrane or brain floating in a higher dimensional space-time called hyperspace. Within this hyperspace, there could be other brains, other universes parallel to ours. Normally, we can't interact with them because all known particles and forces except gravity are confined to our own brain. Now imagine a massive object existing in this multidimensional space. It's not in our universe, but rather in the bulk, hyperspace, yet positioned very close to our brain. We wouldn't be able to see or touch it, but we could feel its gravitational influence. What if the shadow we observed is actually a gravitational imprint or shadow cast by such an object from another dimension? This idea, known as the brain-world model, could explain why we observe a massive gravitational effect, a blocking of light, but see no source for it within our three-dimensional space. The source object simply isn't located here. This was an incredibly bold assumption, essentially implying that the Event Horizon Telescope accidentally photographed the projection of another universe onto ours. This theory solved many issues, the lack of radiation, the absence of interaction with local matter, but it simultaneously raised new, even more fundamental questions. If this is the case, what exactly is this object? What is that universe like? And can we ever truly learn more about it? This hypothesis shifted the entire mystery from the astronomical realm to a metaphysical one. Amidst all these theoretical debates, while astronomers globally focused their telescopes on the mysterious shadow, Dr. Reed's team made a crucial breakthrough. One of her graduate students, a young and brilliant programmer named Ben Carter, decided to approach the problem from a completely different angle. Instead of trying to define what the shadow was, he focused on analyzing its edges with unprecedented precision. He developed a novel algorithm that boosted the resolution of the shadow's boundary by hundreds of times, meticulously analyzing microscopic fluctuations in the light from background galaxies. For several weeks, his supercomputer crunched the data. Then one night, he got the result. The shadow's edge was not perfectly smooth. Under immense magnification, a structure emerged. This wasn't random roughness. It was a complex, almost fractal pattern, repeating with mathematical exactitude. But the most astonishing finding was yet to come. The pattern was not static. It was changing, slowly, almost imperceptibly. It was breathing. The rate of change was minute. One full cycle took several months, which is why nobody had detected it before. This discovery changed everything. The seemingly static, dead shadow was, in fact, a dynamic, living entity. Whatever it was, it possessed an internal structure and was undergoing some form of active process. This immediately ruled out a host of standing hypotheses. A topological defect or a simple void in dark matter would be unlikely to exhibit such complex and regular dynamics. Conversely, this discovery lent credence to the artificial origin hypothesis. Perhaps the pattern represented technological processes operating on the surface of a megastructure, or, alternatively, it was a completely new, natural phenomenon governed by a physics entirely unknown to us. Evelyn Reed's team realized they now held the vital key to the puzzle. Their next challenge was figuring out what this pattern actually meant. The discovery of a dynamic structure at the boundary of the shadow sparked a new wave of interest and controversy. Scientists worldwide scrambled to model the observed pattern. Theoretical physicists constructed intricate mathematical models, attempting to replicate this breathing of the shadow. Some hypothesized it might be surface oscillations of an exotic star composed of an unknown form of matter. Others believed it was related to dark matter annihilation processes occurring at the boundary of the bubble. Ben Carter, the very graduate student who first discovered the pattern, continued his deep dive into the data. He was trying to find some hidden order, some definitive signal within the complex structure. He applied cryptanalysis techniques normally used for breaking codes to the readings. He searched for repeating sequences, mathematical regularities, anything that suggested the pattern was not random. And he found it. Deep within that fractal noise, a simple, repeating sequence was hidden. It was a series of pulses that followed one another in the order of prime numbers, 2, 3, 5, 7, 11, and so on. This couldn't be a coincidence. While nature favors symmetry and fractals, it rarely relies exclusively on prime numbers. This was a clear sign of artificiality. This was a signal. Something or someone lurking behind that shadow was transmitting the simplest, most universal message imaginable, a message any sentient civilization familiar with mathematics would instantly recognize. This was not just a discovery. This was first contact. The realization of this fact hit the team like an avalanche. They had spent years searching for extraterrestrial life, listening for radio signals via Project SETI, and now they had found it where no one expected, encoded within a shadow on a deep space photograph. The instant that sequence of prime numbers flashed across the monitor screen irrevocably altered the lives of everyone present. The initial shock quickly dissolved into euphoria, only to be replaced by the crushing weight of responsibility. They were now custodians of perhaps the most significant piece of knowledge in human history. The immediate question was, what next? Should they reveal it to the world? That risked provoking an unpredictable reaction, ranging from global elation to widespread panic. Governments, organized religion, the entire fabric of human society could be fundamentally destabilized. Or should they keep it a secret until they understood more? But the question haunted them. Did they even have the right to keep this hidden? Following agonizing and protracted debates, a course of action was finally decided. The first step was a triple-blind verification. The raw data was anonymously submitted to 3 independent teams of cryptographers and mathematicians, masked as complex geological readings. All 3 groups, operating in complete isolation, returned the exact same verdict. The sequence was non-random and was, with 99.9% certainty, an artificial, prime number-based signal. All doubt was eradicated. Simultaneously, Evelyn Reed initiated contact with her organization's leadership, eventually escalating the information to representatives of the world's governments. A secret international commission was swiftly established to manage the crisis. Scientists, high-ranking politicians, military leaders, philosophers, and even theologians were brought together to jointly determine the fate of this revelation. The world remained oblivious, yet behind those closed doors, its immediate future was being decided. Humanity was no longer alone in the cosmos, but it had not yet realized it. While politicians and military leaders debated the potential consequences and risks, the scientists pressed on with their work. Their primary mission now was to understand the nature of the signal and, crucially, its sender. They christened the source the shadow. A project was immediately launched to continuously monitor the anomaly's boundary. Every available resource was poured into this singular task. The researchers suspected the signal contained deeper, more complex information. The initial sequence of prime numbers was merely a calling card, a way to capture attention. Something far greater had to be hidden behind it. Employing increasingly sophisticated analytical methods, they discovered a second, far more intricate layer of data encoded in the subtle changes in the intensity and polarization of light along the shadow's edge. This was no longer a simple sequence, it was a massive trove of raw data. The long, painstaking process of decryption had begun. It was akin to trying to read a book written in an utterly unknown language without so much as a basic dictionary. Linguists, mathematicians, and information theory specialists worked around the clock. They searched for universal concepts that might form the bedrock of this language, mathematical constants like pi or Euler's number, fundamental laws of physics, or atomic diagrams. Step by step, bit by agonizing bit, they began assembling this incredible puzzle. The first breakthroughs were visual. Schematics resembling blueprints began resolving on their monitors. These were images of stars, galaxies, and, most astonishingly, a schematic bearing a striking resemblance to the very device they were using, the Horizon's Eye telescope. They knew we were watching. They hadn't merely sent a signal into the void, they were answering us. Realizing that the shadow didn't just exist, but was actively observing and responding to us, was a second shock wave, just as profound as the first. This changed everything. It wasn't a monologue, it was a dialogue. But who was on the other end of that conversation? The decrypted data offered no answers. There were no images of the creators, no texts detailing their history or culture. The entire dataset was purely scientific and mathematical. It was an encyclopedia of the universe gifted to us, knowledge that surpassed our current understanding by hundreds, perhaps thousands of years. It contained the formulas for the unified field theory that Einstein spent his life pursuing, maps detailing the distribution of dark matter across the cosmos with staggering accuracy, technologies for manipulating gravity and traversing wormholes. This was a gift of unimaginable value. Or was it a Trojan horse? Certain members of the secret commission voiced immediate concerns. What if this knowledge was inherently dangerous? What if, in attempting to use it, we inadvertently triggered our own destruction? Was this a test to see if humanity was mature enough to wield such power? Or perhaps worse, a vector for transmitting a virus, be it informational or biological? The debates grew increasingly fierce. On one side lay the potential to solve all of humanity's problems: hunger, disease, the global energy crisis. On the other, the distinct risk of total annihilation. Humanity stood at a profound crossroads, facing the most critical decision in its history. So, what exactly was the shadow? The deciphered data finally provided the answer. It wasn't a Dyson sphere or a simple cloaking device in the conventional sense. It was a calculating machine the size of a star system, a colossal computer whose entire physical matter had been converted into a computational substrate, what is known as computronium. It drew power not just from a single star, but from the entire star cluster housed within its volume. This explains why we observed neither light nor heat. All energy was channeled directly into processing data. The machine's sole purpose was knowledge acquisition. It was built by a civilization that had long abandoned its biological form, transcending to a higher plane of existence by becoming pure intelligence. This construct served as their home, their ultimate body, and their instrument for exploring the cosmos. For millions of years, it accumulated information, constructed sophisticated models of reality, and solved the most fundamental riddles of existence. And now it had finally noticed us. A young, noisy, chaotic civilization dwelling on a small planet orbiting an unremarkable star. And it decided to share its knowledge. This was not an act of altruism as humans understand it. Rather, it was similar to a master scientist sharing a groundbreaking discovery with a promising colleague. They recognized our potential, that nascent spark of consciousness, and decided to help us take the next evolutionary step. The shadow was never just an object. It was a mind, ancient, immensely powerful, and utterly incomprehensible. The knowledge transferred was organized into several distinct tiers. Tier 1 contained foundational physics and mathematics. It was considered relatively safe and could be released to the public without major risk. Tier 2 focused on applied technology, new energy sources, material science, and biotechnology. This level was strictly classified due to its high potential for military application. Tier 3, the deepest level, was heavily encrypted. Scientists theorized it held secrets about the creators themselves, their philosophy, and possibly information regarding other civilizations throughout the universe. Alternatively, it might contain technologies capable of destroying stars and galaxies. Access to this tier was strictly forbidden until further notice. A quiet scientific revolution was already underway. Under the direction of an international commission, highly secure research institutes were established across the globe. The planet's greatest minds began working tirelessly to apply this newfound knowledge. The initial results were staggering. They rapidly developed a prototype cold fusion reactor, a device that could power an entire city using nothing more than plain water. New materials were engineered, light as plastic yet strong as diamond. In medicine, breakthroughs began in treating genetic diseases and, crucially, aging itself. Humanity stood on the precipice of a golden age. Yet all of this progress unfolded in complete secrecy from the general public. The official story remained the same. The shadow was merely an unexplained natural phenomenon, perhaps related to dark matter. But the question remained, how long could they keep the truth hidden? A few years later, the inevitable finally happened. The information leaked. One of the scientists working on the secretive project had grown disillusioned with the politicians' extreme caution and slow pace. He believed this knowledge belonged to all of humanity and that keeping it hidden was a crime. He passed some of the Level 2 data to a renowned investigative journalist. The resulting publication created a shockwave that surpassed even the wildest expectations. The world erupted. Initially, there was widespread disbelief and accusations of an elaborate hoax. But when independent experts verified the data's authenticity, and some major corporations even presented working prototypes based on the revelations, denying the truth became impossible. Society's reaction was turbulent and deeply contradictory. Some felt elation and hope for a brighter future. Others felt crippling fear of the unknown, wary of Greeks bearing gifts. Religious organizations faced an existential crisis. Conspiracy theories sprang up like mushrooms after the rain. Some saw it as a government deception designed to establish a new world order. Others believed it signaled the start of an alien invasion. Riots broke out, economic crises mounted, old alliances collapsed, and new ones began to form. Humanity proved utterly unprepared for such a gift. The truth did not set us free. It plunged the world into chaos. The period that would later be known as the Great Upheaval became the most difficult test in the history of civilization. It became starkly clear that the greatest challenge was not acquiring the knowledge, but knowing how to manage it responsibly. Even as chaos erupted across the earth, the dialogue with the shadow persisted. But the nature of that dialogue had fundamentally shifted. Humanity, speaking through the International Commission, finally started asking the big questions. They moved beyond mere science, delving into philosophy, ethics, and the very meaning of existence. The answers arrived in the same dispassionate form, complex mathematical and logical constructs utterly devoid of emotion. The shadow offered no advice and never imposed its perspective. It merely provided raw data, modeled potential futures, and outlined the consequences of specific choices. It was not a teacher, but an instrument, powerful, yet wholly impartial. From these responses, a picture of the shadow's own history began to emerge. The civilization that created it had faced a similar existential crisis billions of years ago. They too nearly destroyed themselves when they accessed technology that outpaced their social and ethical development. But they survived, united, and chose the path of pure knowledge, forsaking power and expansion. They transformed themselves into the shadow, becoming eternal observers and custodians of knowledge. They refrained from interfering with other civilizations' progress, but if they recognized potential, they provided a chance, a catalyst, just as they had done with humanity. Their belief was that every sentient race must walk its own path, make its own mistakes, and find its own answers. They were not gods, they were gardeners who planted seeds across the universe and waited to see which ones would flourish. The crisis on Earth, like any violent tempest, eventually began to subside. Confronted with the immediate prospect of self-destruction, humanity finally found the strength to pull back from the brink. The very technologies that had initially fueled global conflict gradually started to bear fruit. Abundant, low-cost energy eliminated hunger and poverty. Breakthroughs in medical science conquered most major diseases. The threat of global war finally receded when it became chillingly clear that at this new level of technological power, any conflict would inevitably be the last. A slow and arduous process began, building a new global civilization, founded not on fierce competition, but on committed cooperation. The shadow became woven into the fabric of culture. For some, it was a symbol of hope; for others, an eternal reminder of our collective responsibility. Decoding its signals became humanity's premier scientific endeavor. Interstellar travel, once a distant dream, became reality. Humanity began to venture into the cosmos no longer as a conqueror, but as an explorer, a student. We had finally matured. The Enigma that began as a small black smudge on an astronomical plate ultimately served as the catalyst for humanity's profound transformation, a true new stage in its evolution. It forced us to look outward at the stars, yes, but more importantly, to look inward at ourselves. So let's go right back to the very beginning, to the precise moment an astronomer first spotted that anomaly on their screen. What was it? An instrument malfunction? A dark nebula? A black hole? As it turned out, the reality was far stranger and more astonishing than anyone could have predicted. This story, though entirely fictional, perfectly illustrates a crucial principle of scientific inquiry. Every new mystery, every anomaly that defies existing theories, it's not a problem, it's an opportunity. It is a window into a new, uncharted world. The history of science is filled with such examples: the discovery of X-rays, radioactivity, cosmic microwave background radiation. All of these began with observations that flat out contradicted the accepted knowledge of the time. Astronomers looking through their telescopes are essentially doing the exact same thing. They are searching the silent vacuum of space for these shadows, these anomalies that could hold the key to the next scientific revolution. Every new discovery is one more step on the endless path toward understanding the universe and our place within it. And who knows, maybe right this very second, some real-life telescope is gazing into a dark corner of the sky and documenting something that will change our future forever. Reflecting on this story forces us to question the very nature of contact. We are used to imagining encounters with extraterrestrial intelligence straight out of Hollywood scripts: flying saucers, little green men, and Star Wars battles. But what if genuine contact is something else entirely? What if it's quiet, almost unnoticeable, maybe even academic? What if the first sign from another civilization arrives not as a radio message, but as a strange gravitational field, an anomalous chemical composition of a distant star, or perhaps a mysterious shadow like this? The universe speaks the language of physics and mathematics, and perhaps that is the very language in which our first dialogue will take place. A civilization capable of creating megastructures will likely be so radically different from us that direct communication will be impossible. Their thoughts, their motives, even their self-perception may be utterly incomprehensible to human minds. Transmitting fundamental knowledge is, perhaps, the only universal method of communication comprehensible to any technologically advanced species. It's akin to leaving a highly advanced textbook in the wilderness for a tribe you know you will never encounter. The story of the shadow is a reflection that we should not be searching for intellectual brethren, beings similar to us, but rather for teachers who may be utterly inscrutable, yet whose lessons we can still strive to understand. This story also raises a crucial philosophical dilemma: the relationship between knowledge and responsibility. Imagine you suddenly gained access to absolute knowledge. How would you wield it? Would you leverage it solely for personal gain? Would you share it with the world, potentially unleashing chaos? Or would you perhaps conceal it, deeming humanity too immature to handle the truth. This is far from a hypothetical scenario. Our own history demonstrates clearly how scientific breakthroughs can lead simultaneously to the greatest progress and the most horrific disasters. The discovery of nuclear fission, for example, delivered both atomic energy and the devastating potential of nuclear weapons. Advances in genetics promise the eradication of disease, yet they also carry the inherent risk of creating so-called designer humans or developing catastrophic biological weaponry. Every new frontier of knowledge becomes a rigorous test of our collective wisdom and morality. The shadow civilization in our narrative made their choice. They imparted their knowledge, yet chose not to interfere with how we utilize it. They essentially gave us the power to either ascend or to utterly fail. And perhaps that neutrality holds the most profound lesson of all. True evolution isn't just about technological progress. It is the maturation of our ability to manage the immense power that progress grants us. Without that foundational wisdom, even the greatest knowledge imaginable risks becoming nothing more than a profound curse. But let's pivot slightly from the global big picture and get back to astronomy. Are there any real-world candidates for these shadows we've been talking about? While direct parallels certainly don't exist, there are objects that still genuinely baffle scientists. Take, for instance, Tabby's star, or KIC 846-2852. This object displays very strange and irregular dips in brightness that cannot be explained either by the presence of planets or by any known stellar processes. One of the most exotic hypotheses suggested that a swarm of alien megastructures was orbiting the star. While most scientists now lean toward more natural explanations, like a giant cloud of comets, the mystery of Tabby's star remains completely unsolved. Another example is the so-called supervoids, or just voids. These are giant regions in the universe that are practically devoid of galaxies. Some of them, such as the Eridanus void, are so massive and empty that their existence poorly aligns with our standard cosmological model. Of course, these aren't shadows in the precise sense we described, but they are anomalies that suggest our understanding of the large-scale structure of the universe might be incomplete. Every such strange occurrence is a crucial lead, a thread we can pull to unravel an entire tangle of new knowledge. Let's pause for a moment and imagine that this shadow actually exists. How would its presence truly impact our daily lives, our sense of reality, our entire worldview? Initially, perhaps the impact would be negligible. For most people, it would just register as another abstract and distant scientific headline. But over time, as this new knowledge and technology began to permeate every aspect of our existence, the changes would become irreversible. Imagine a world without disease, without poverty, powered by virtually limitless clean energy. A world where space travel becomes utterly commonplace. This wouldn't just reshape our economies and political structures, it would fundamentally alter our very psychology. What would humanity do when the daily struggle for survival is removed? What new goals would we pursue? Perhaps we would dedicate ourselves more fully to creativity, science, and self-improvement. Or, conversely, we might sink into apathy, idleness, and virtual escapism. Contact with such a superior intelligence could become the catalyst for either the greatest flourishing or the profoundest spiritual decline of mankind. This would be an existential choice that every single person would have to confront. The presence of this shadow hanging over us would serve as a permanent, humbling reminder. We are not the pinnacle of evolution, merely one step on a much longer path. Another fascinating aspect of this story is the role played by one individual, PhD student Ben Carter. It was his unconventional approach, his decision to look at the data from a completely different angle, that ultimately led to the breakthrough. This is a recurring motif in the history of science. Major discoveries aren't always made by grey-haired professors in large, prestigious offices. More often they come from young, audacious minds, unburdened by dogma or the weight of established authority. Think of Einstein. He was just a clerk in a patent office when he wrote his revolutionary papers. Or Jocelyn Bell, who discovered pulsars while she was still a graduate student. This story is a powerful reminder that in science, it's not just the sheer power of our instruments that matters, but the freshness of our perspective. Sometimes seeing what others miss simply requires asking the right question or adopting an unorthodox method. And perhaps the key to the universe's greatest mysteries is lying right now in the raw data gathered by some random telescope, just waiting for its own Ben Carter to come along and spot it. Science is built not only on knowledge, but also on imagination, intuition, and the courage to go against the tide. These are the very qualities that drive progress forward, moving us from one solved enigma to the next. Let's take a moment to consider the sheer scale of time. The shadow in our narrative has existed for millions, perhaps even billions of years. It witnessed the birth and death of stars, the genesis and ultimate collapse of countless civilizations. To this entity, the entirety of human history is nothing more than a fleeting moment, a single, flickering frame in a vast cosmic chronicle. This realization helps put our own struggles and triumphs into their proper perspective. What we perceive as eternal and absolute, our nations, our cultures, our very conflicts, is, from the universe's standpoint, merely a slight ripple on a vast ocean. Understanding these profound timescales can be both terrifying and liberating. It forces us to confront just how small and insignificant we truly are, yet simultaneously it underscores the immense value of our brief flash of existence. We are the consciousness of the universe, the part that gained the ability to look back upon itself, to ask questions, and to tirelessly seek answers. Even if our existence is but a fleeting blink, within that moment we can touch the eternal through knowledge and discovery, and perhaps this is our most profound mission of all. The civilization of the shadow chose its own path, to transcend physicality and become an everlasting consciousness. Only the future will reveal the path humanity chooses when our own time of reckoning finally arrives. In our narrative, the shadow turned out to be a source of knowledge, yet it could just as easily have been something radically different. What if it wasn't some intelligent creator, but rather a purely natural phenomenon governed by physics we simply haven't discovered yet? Imagine, for instance, a stable wormhole leading to another universe entirely, one with fundamentally different physical laws. Any light that entered it would simply vanish from our existence forever. Or perhaps it's an object made of mirror matter, that hypothetical form of substance that interacts with our reality only through gravity. Such an object would be perfectly invisible, yet powerful enough to completely block the light from background celestial bodies. The cosmos may be absolutely teeming with phenomena we currently lack the capacity to even conceive of. In a way, we are like people living on the deep ocean floor, attempting to judge the entirety of the world based only on the faint, distorted light filtering down through miles of water. Every new tool, every new telescope we build is our attempt to rise just a little higher to see further and clearer. And every new discovery expands our horizon, revealing that the universe is infinitely vaster, more complex and more breathtaking than we could have possibly imagined the day before. The mystery of the shadow, even if it were proven to be nothing more than a rare natural phenomenon, would still stand as a monumental discovery, one that would compel us to completely rewrite our physics textbooks. Let's bring the focus back to you. What would you have done if you were Evelyn Reed or Ben Carter? Imagine you were the first one to see that signal, the first one to truly grasp its meaning. Would you tell anyone? Would you try to leverage that knowledge for personal gain? Or would fear take over, making you try to hide the whole thing? This thought experiment helps us grasp the immense complexity of the choices real scientists face every day. The responsibility resting on the shoulders of a pioneer is truly immense. The fate of countless people might hinge entirely on their decisions. In our story, the protagonists chose a path of caution and collaboration, which ultimately saved humanity. But history offers us countless different examples. Science is not a sterile field of pure, abstract ideas. It is made by living, breathing people with their own ambitions, fears, and weaknesses. That is why it is so crucial for the scientific community to maintain strong ethical principles, a system of checks and balances designed to minimize risks and direct the power of knowledge toward the greater good. The story of the shadow is, in many ways, a modern parable about the moral choices facing scientists and their ultimate duty to society. And so, our lecture draws to a close. We have journeyed a great distance, starting with a simple dark spot on an image and ending with profound reflections on the fate of civilization itself. We explored countless hypotheses ranging from the most straightforward to the truly fantastic. We saw how one singular enigma can become a powerful catalyst for incredible scientific and social progress. This story, of course, is a work of fiction. As of today, astronomers have not detected anything resembling the shadow we described, but it is deeply rooted in real scientific ideas, the real questions that scientists ask themselves as they look out into the night sky. What is dark matter? Do other dimensions truly exist? Are we, in fact, alone in the cosmos? These are questions for which we do not yet have answers. Yet every day, every single night of observation brings us closer to finding them. And who knows? Perhaps the headlines tomorrow will announce a discovery even more profound and surprising than the story you've just heard. The universe is filled with mysteries. And the most compelling aspect of science is this: for every enigma we solve, a new, even more interesting one immediately emerges. The journey of knowledge is endless, and we are truly only just beginning. So what was it, really? A perfectly black shadow without an object, a void that proved not to be emptiness but a formidable presence. The presence of a mind so ancient and powerful it had converted an entire star cluster into a massive, functioning computer. What began as a mere astronomical puzzle quickly escalated into first contact, and the greatest challenge humanity has ever faced. This was more than just a scientific finding. It was both a gift and a curse, knowledge capable of lifting our civilization to the stars or plunging it immediately into chaos. This story demonstrates that the most unbelievable discoveries often hide within the smallest details. In anomalies we initially dismiss as errors or background noise. It serves as a potent reminder that the universe is far stranger, far more complex, and infinitely more astonishing than we are capable of imagining. And the most profound question it forces us to ask is not, are we alone, but rather, are we truly ready to not be alone? Thank you for spending this time with me, delving into this cosmic mystery. I sincerely hope this journey was both peaceful and intriguing for you. Don't forget to subscribe to the channel so you don't miss out on our future sleep lectures. Hit the like button if you enjoyed this story. And in the comments below, let me know, what do you think is truly hiding in the darkest corners of our universe? Good night and sweet dreams.